On January 4th, 2021, Slack experienced a global outage that prevented customers from using the service for nearly 5 hours. Slack has released the root cause analysis incident report, which I'm going to summarize in the first part of this video. After that, I'll provide a lengthy, deep dive analysis of the incident, so make sure to stick around for that. If you're new here, I make backend engineering videos and also cover software news, so make sure to like, comment, and subscribe if you would like to see more. Plus, it really helps the channel. Let's just jump into it. So this is an approximation of the Slack architecture based on what was described in the reports. Clients connect to load balancers distribute requests to the backend servers, and finally backend servers make requests to database servers, which is powered by MySQL through vitess sharding. All of those are connected by routers in cross-boundary network in the cloud provider, which I believe it's AWS. Around 6 a.m. January 4th, the cross-boundary routers sitting between the load balancer and the backend to DB started to drop packets. This led to the load balancer slowly marking backends as unhealthy and removing them from the fleet, which compounded the amount of requests coming from the client. The number of failed requests eventually triggered the provisioning service to start spinning an absurdly large number of back-end servers. However, the provisioning service could not keep up with the huge demand and shortly started to time out for the same networking reasons and eventually ran out of maximum open file handlers. Eventually, Slack Cloud Provider increased the network capacity and backend servers, and everything went back to normal at around 11 a.m. PST. This was a summary of the Slack outage. Now sit back, grab your favorite beverage, and let's go through the detailed incident report, guys. All right, guys. So Slack have released the final root cause analysis report, and now we know what caused the outage that happened on January 4th, 2021, Monday. People just returning to work. I don't envy the Slack engineers that had to kind of suffer this in the beginning of the year, man. Usually at the beginning of the year, things are slowing down. We don't have much work to do. Like, checking email, do sus. I don't envy the Slack engineers, but they did a pretty good job. But guys, from the issue summary here, we're going to read it in a minute, but whatever happened to that outage, unlike the Google outage, unlike the Amazon outage, unlike the Microsoft outage that I talked about, Slack has no fault here. It's all the cloud provider, in my opinion. If the network just, the infrastructure underneath you just started falling apart, what can you do? You don't have any choice, right? So the networking infrastructure, the routers, right? This is no fault of Slack, in my opinion. But as I explained in the summary, however, I think they could have done in the remedy section that we're gonna go through, they could have done few things to avoid that problem, at least minimize it. Let's go through this. Let's go through a report. Grab your favorite beverage and let's sip and then enjoy. Issue summary. Starting around 6 a.m. PST on 2021, January 4th, some customers started experiencing occasional errors and increased latency while using Slack. I started getting tweets at the same exact time. I wake up around 5 a.m. every morning. So I started getting tweets actually before that, maybe around 5:30, I started getting the tweets, right? And some of you say, hey, Hussein, talk about the Slack outage. What Slack outage? Like, I don't even use Slack. I have Slack on my phone, but I only subscribe to HA proxy community. That's the only thing, and I barely look at it as well. So, yeah, so then the tweets started raising, and they said, okay, this is a real outage. Around 7 a.m. PST, there was a rapid increase in errors, and Slack was not usable for all customers. Around 8:45 a.m. PST, some customers began to see improvement, but others who were trying to launch their Slack clients were not able to do so. By around 9:15 PST, most customers were able to use Slack again normally. We continued to experience elevated errors until 10:40 a.m. PST, after which all customers were able to use Slack again normally. So around 4 hours 40 minutes, so 5 hours almost. So yeah, that's not so bad if you think about it. And I know we made in the early report video that I made a lot of, I guess, assumption and assertions, right, related to the cache, because they ask customers, hey, do a control F5, whatever that command, to do a full refresh or a hard refresh, right? And now it makes sense based on the summary, right? We're gonna go and talk about that. The root cause. Around 6 a.m. PST, we began to experience packet loss between servers caused by a routing problem between network boundaries. And that's an interesting name, network boundaries, on the network for our cloud provider. So they didn't specify what is their cloud provider, but I googled it. It's AWS. I don't know why wouldn't they mention it here, like it, but it's clear it's AWS. Looks like it, right? By 6:30 a.m. PST, the packet loss began to worsen. Is that even a word, worsen? Can you say worsen, English people? Worsen? I guess worsen. Causing increased error rates from our backend servers. We were paged at 6:46 a.m. PST due to high error rate. So that's when they actually got notified. So it started at 6 a.m. They were paged 40 minutes later because of the increased amount of error. But essentially, they didn't get, remember guys, they didn't get paged because of packet loss. And that's something they're gonna remedy. Because if they got paged or they got some monitoring, they say, hey, there's a lot of packet loss, what's going on? No, the packet loss led to servers being unresponsive, and as a result being removed from the fleet, and as a result increased errors, and that errors got triggered. So that's something we see very, very, very common pattern with Google as well. The root cause didn't trigger the paging, right, to the engineers, so they didn't know as early as possible. The ramification downstream effect is what caused the paging, right? The notifications to the engineers that, hey, something is going on, right? This is a very common pattern, and it's being the same thing with Amazon happened. I remember Google, same exact thing. They didn't get, when their quota went to 0, they didn't get notification, right? They got notification when actually the users couldn't authenticate, which is a downstream effect as a result of this. Very, very common things in engineering. We see it all the time. It's not what you think it is. It's always something else that caused the problem, right? And what do you do as engineers? You try to kind of remedy that by trying to understand it better. In addition, many backend servers were busy servicing high latency requests due to network problems between our backend server, because most of these requests are synchronous, right? The load balancer or the backend server will make a request and then just wait for a response. And that doesn't mean necessarily that the backend is actually chunking or the database is chunking the request and servicing it. No, it's just the network to make the TCP packet. I don't know if you use TCP, but I'm just assuming that to make sense of the packets to actually form a logical request, that is not even reaching that state to the client, which is the backend in this case. My request is not getting serviced, but the packets that assembled, the multiple packets that assemble into a logical request is not even serviced. That's the problem here, right? At least that's what I'm analyzing right here, right? Because once the request reach the server, I mean, the processing power is there. We have that, right? The problem here is just networking. Man, you see this very clearly. If you build an app that connects to a database, right? And the database, usually database apps are chatty in general, right? Because you need to start transactions, create cursors, execute queries, and you have to execute many queries. And there's the protocol of the communication between the database and the backend is always chatty, regardless, right? That's why I always say keep your servers close and your database closer, right? Keep your database as close to as possible to the server within the same network to avoid that latency. Because the chattier your app becomes, of course, the best thing is just make it less chatty. But the chattier it becomes, the more prone to errors, the networking errors it becomes, right? Because every request now it goes to the network, and then all these networks start to segment multiple segments, right, which is packets, and then all these packets have to be delivered, and one of them, if it didn't deliver, you have to retransmit, and all this is happening beneath you as a backend application. You have no control over this. To you, the request has not been sent yet, right? But all of this request, man, well, these high latency requests were only 1% of the incoming request, they used about 40% of the server time, right? All these requests are just waiting for responses, but they can't because of this problem. Then obviously when you wait for something, apparently that tells me they don't have enough timeout set up, right? Because if you have enough timeout, you just like kill it very early. And that's a very interesting problem, because I can't possibly suggest a one timeout that fits all, right? You have to at one point you have to specify, if a request is taking so much time that it's actually overwhelming your server, you have to kill it, because there's no way you're waiting for this stuff. And that's as to me, as I hate to say that, but it's a trial and error in my opinion, right? Because you say you have to know like what are the parameters to stop, or what are the parameters that says, okay, this request should finish within 3 milliseconds or 500 milliseconds, or sometimes based on the parameters or the input of the request, that can take up to a second. Who knows, right? So timeout is one of the most important things, and obviously goes to the circuit breaking if you have a chain of these things. Very, very interesting. I don't know if they took this into consideration or not. Subsequently, our service discovery system marked many backend servers as unhealthy due to the networking problems. Obviously, if the load balancers start making requests to the backend, which turn around and make requests to the database, which is vitess, by the way, I talked about that the other day. Which it's not, the database is not vitess. The database is mysql and sharded by vitess, which is a sharding layer that's just removes the application logic sharding down to a tablet that is controlled by vitess. Yeah, so the load balancer at the end of the day, make a request to the backend, and the backend is not responding, and it says, yeah, well, I don't know what's wrong with this backend, but I'm removing it from my fleet. Right? And we talked about that in HA proxy, right? And how HA proxy can mark a backend as unhealthy, right? Or unusable. It just will drop it from the fleet of servers, and it will mark it as just essentially unhealthy, so that it won't send request in the future to that backend. The network problems worsen, which significantly reduced the number of healthy servers. By 7 a.m. PST, there was an insufficient number of backend servers to meet our capacity needs. Customers either could not load their Slack clients or saw error pages directing them to the Slack start page. Because now, if you don't have enough backend server to serve all these massive amount of requests, the load balancer will have only few servers to work with. And guess what? As a result, either you're going to timeout at the load balancer side, not the backend, it's just earlier, or you're going to get errors, or you're going to get all sorts of weird things. So what happened next? Our backend server fleet then began to automatically scale up to meet the traffic demand. So this is all happening without them, right? They didn't trigger anything. They were paged at 6:40 a.m. By 7 a.m., they started automatically scaling up. And guess what? They almost have no servers at this point. So what does the automatic scale up? And that comes to the parameter and AI and all that stuff, right? The automatic parameter said, oh, well, you don't have any servers. I'm going to spin up 1,200 servers, which is absurdly unrealistic if you think about it, right? Just what happened? What is going on? You spend 1,200 servers? Obviously, the automated scale up is based on some human algorithm that someone put there, right? But between 7 a.m. and 7:15 a.m. PST, our automation attempt to simultaneously add 1,200 servers to the backend fleet, a much higher rate of server provisioning than we normally handle. Who's going to handle that 1,200 server add in a given in 15 minutes? That's just ridiculous, right? I don't know if Google does that even. Our provisioning service, which configures new servers in cloud environment, had 3 problems. So now the cascading effect comes to play, right? That we talked about. We have the networking cause the load balancer to drop backend servers, which then triggers the provisioning services. Hey, you don't have any servers. Let me spin up some service for you, son. So here's the problem for the provisioning service. It was unable to keep up with the multiple tasks of configuring servers at the requested rate, because when you spin up a request server, you have to configure it, put the necessary app, version, whatever, pull from GitHub or your source repository, install the runtime. If it's a VM, spin up the right VM version, whatever then install the app, run them, configure them, put the configuration, all that stuff, plus DNS configuration, resulting in unhealthy servers in the fleet, right? So it couldn't even keep up with the amount of work that it needs to do, because the provisioning service is just another service, right? And if the service is facing another networking problem and the load of 1,200 servers to configure that, which they didn't anticipate, it's going to go down. Provisioning began to take increasing amount of time until it reached 30 minutes, which is when the operations timeout. So they have a timeout of 30 minutes in a single server. And if you ask this poor service to spin up 1,200 servers, eventually it's going to run in parallel, right? I'm going to spin 1, 2, 3, 4, 4. But at one point, it will just slow down, right? It will say, hey, I can't handle concurrently spinning up this much server. So it will basically have less and less and less resources. And as a result, the provisioning time will go up and up and up and up until it hit the timeout, reach 30 minutes. All you have is a bad configuration left. You have a server that is bad. It's unusable. The service ran out of open file handles because it kept an open file handle for each server. Then it attempt to provision, and it was provisioning more machine at once than we had load tested for. So is it safe to say that the maximum file handlers were 1,000? I think this is a little bit low. I don't understand this. I would like someone else anyone actually can explain this better, because file handlers in Linux, I'm not very proficient in Linux and Unix system, but I know that file handlers are opened with networking sockets, and I know that the default limit is 10,000, I think, right? So there is the open file handlers are maximum is high. So I don't know why they hit that so early, spinning up just 1,200 servers. I might be wrong. There must be something missing that I don't know about. That I appreciate anyone from Slack or anywhere else who can explain this. I'm just curious. This service ran into API rate limit from some of our cloud providers' API, which slowed down the provision operation further. Oh, okay. So apparently AWS, which they didn't say, have to provision these servers. They have a rate limited. You cannot just spin up as much VMs or as much EC2 instances. I'm just assuming there's EC2. I'm not sure. You cannot just like spin up willy-nilly, right? They have a rate limiting, and that service hit the rate limit. To me, these are not problems, in my opinion. You should not be worrying about provisioning 1,200 servers, right? I think this is wasted engineering efforts, in my opinion. Why would you? This is over engineering. You're going into the wrong direction, in my opinion, Slack. You're fixing a problem that shouldn't happen in the beginning with. I don't think if you made this provisioning service accept higher and higher rates, yeah, you just made the process a little bit faster, but the cause of the problem is networking, and I don't think you could do anything about it. Fix the root cause. That shouldn't reach. You shouldn't reach a state where you need to spin up a 1200 server in 15 minutes. I don't think so. So spend those resources, in my opinion. If I wouldn't do this, I would spend it on getting a better network capacity, dedicated network capacity for you, so you don't even run into this problem. Avoid network cross-boundary networks with different subnetworks, right? So make sure the backends and the database are in the same subnet, so you avoid routing as much as possible. Everything is within the same network essentially, so that minimizes these things. This makes sense to me. This, I'm not sure. Let me know, guys, if you disagree with my statement. I don't think this is a well-spent effort. Spending time to kind of increase the API rate limit for this. What would that add you, right? Just you're gonna spin. Plus, if you're gonna spin up, the next time you spin up new servers, they're gonna go down because of the same problem, the networking problem. So you can't possibly spin up enough servers to keep up with the root problem, which is this latency, which is the dropped packet, which is, I think, there's some sort of threshold that AWS has just hit with you guys. This happened in large part because our provisioning service failed under the unprecedented load of provisioning requests. Well, of course, it's gonna fail. It was what the hell is this word? What is this word? Exacerbated? Ugh. Excuse me, guys. English is not my first language, so you can make fun of me. But I had to look this up. Exacerbated? What the heck is exacerbate?
Exacerbate.
What?
Exacerbate.
Exacerbate? Okay. Exacerbate. Make a problem, bad situation, or negative feeling worse. Oh, to make something worse, exacerbate. Can't you just say make something worse? Okay. It was exacerbated by the I can't say it. It was exacerbated by the outgoing network problems, which caused some newly provisioned servers to have problems contacting the provisioning service or the configuration service. And those machines could not get far enough through the provisioning process to start their service. We talked about that, the timeout 30 minutes, right? Both of these causes resulted in partially provisioned servers, which are useless, which could not take traffic. Eventually, I'm glad that they didn't accidentally add that, because I would imagine myself doing a bug like that. I wouldn't, for example, I would not anticipate that the provisioning will complete successfully, right? Because I wouldn't test, for example, I would have missed the testing of 30-minute timeout. So I was like, hey, provisioning complete, let's add it to the fleet. Half-assed like that. And then the load balancer would say, share, let me just route traffic to this half-assed server. And I don't want to imagine where we'll go after that. So obviously that they thought this through, which is awesome. To me, I would admit if I would make stupid mistakes. And this is a mistake that I would definitely have make. Right? I would not think about that. Oh, by the way, provisioning couldn't always be successful because of a timeout. Like, how can I think about that? And you have to get hit once by the problem in order to learn from it. And now that I know in the future, if I ever provision something, I know to think about that. A half provision server. Our observability platform was also not reachable for most of the incident because its connection to the database was subject to the network instability. We always see this. Amazon outage, the Google outage, the Microsoft outage hit exactly the same problem. Because of an infrastructure problem, the ability to observe was severed. You cannot even observe what's going on. It's like a reverse Schrodinger's cat, right? You want to look, but if you look, you're dead. You can't even look. So it's just done. So that's the same thing. Because they're using part of their infrastructure as observability, You can even look what's going on. And now that we know about this, the observability are really, really important to keep the observability fleet as separate as possible. And they're going to discuss how they're going to do this in the corrective action. This complicated our debugging efforts and extended the time of recovery. We attempt to pre-provision observability platform servers for troubleshooting, but we were unable to do so due to the problems with provisioning service. Why am I talking like South African accent? We began to do direct queries to our metrics backend. Around 8:05 a.m. PST, we diagnosed that our provisioning service had run out of open file handlers. We fixed that by increasing the file handle limit at 8:13 a.m. Can you share with us what is the file limit? I'm just really interested. We were then able to successfully provision servers which entered service and served traffic. All right, finally they increased the provisioning. They also increased the timeout from 30 minutes to whatever. They don't really need to exceed the timeout, I guess, because the problems were mostly because of the maximum open file limit, which indicated that our cloud provider network stability have improved. All right, so the network stability, which is the root cause, which I guess, guys, it's like I don't think you can do anything about this. The underlying network is just unstable. What can you do? And it makes me think like we're dependent on things that we take for granted. Right? So network engineers, guys, you have a big job when it comes to backend engineering. My God, look at this. Like network engineering is really, really tough. I mean, imagine, if your network, and you might come back and say, it's like, Hussein, if your electricity is gone, you don't even have anything. Of course, yeah, the most important thing is electricity. If you don't have electricity, you don't have any of that stuff. Unless Elon Musk started making batteries for computers. That would be awesome. We later were told by our cloud provider that during this time period, they increased their network capacity in an effort to reduce the instability. We then provisioned new backend servers and observed them successfully taking production traffic. We worked with our cloud providers to lift the rate limit, which were restricting how quickly we can provision new machines. Why am I shifted the accent to an Iranian accent all of a sudden? We steadily increased our backend server fleet size and began to see successful customer traffic. By 9:15 PST, customers were able to use Slack again. We continued to experience elevated error due to network instability until 10:40 a.m. PST. When our cloud provider had finished increasing their capacity, all customers were able to use Slack again. So, increase their capacity. Very interesting. It looks like Slack had hit some sort of a limit they didn't tell us about. And that limit, the networking limit, just started. It's like, hey, you hit your maximum upload or download bandwidth. That would be really weird. You hit that limit. And AWS, why wouldn't AWS just tell you that, hey, you hit their limit? This, again, Slack did not explain what that is. And I saw, and we're gonna read about that in a minute. There is another root cause analysis that we don't have access to for public. That Slack asked the cloud provider, which I think it's AWS, again, they didn't mention, of what caused the network latencies and the instability. I need to get my hand into that stinking report to know what goes on, really, because we still don't know what caused it. Is it a threshold? Is it just because a cross boundary, you're going out of your network and that has a limit? Guys, I don't use your AWS. If any of you use AWS, do you guys have some sort of a limit between cross boundaries? Like if you have a network, I think they call it BP virtual network or something like that, where you can create multiple virtual network. And if you go across these virtual networks, then you are penalized essentially because you're going cross boundary. they charge you something, and maybe they put a limit there. I'd like to know about that architecture. I know nothing about that stuff, and I'm making assertions here. So stop me if I said anything stupid. I'd love to be corrected, obviously. Corrective action. So what they did to fix this stuff. We have completed our detailed investigation and compiled our corrective action to prevent future incidents of this kind. Our cloud provider has increased the capacity of their cross-boundary network traffic system. Okay, so there is a limit capacity to the cross-boundary traffic system, so between a network to another network, as well as moving us from shared to a dedicated system. Aha! You guys were shared. You were using a shared system. So you were moved to a dedicated networking. So you were shared with others. Obviously, the whole thing is built, I would assume, until some sort of a SDN, software-defined networking, right? And encrypted and all that stuff, right? In order to share the system. This SDN, the software-defined stuff, this is the future, guys. I used to kind of underestimate this stuff, but man, that is very important to cloud infrastructure, because you build one network and then you virtualize the networking on top of that, right? And then you create virtual boundary on top of that. Obviously, that adds a little bit of a latency, I would assume, but I don't know how much compared to bare metal networking. Love to know that stuff, but again, I'm not a network engineer. They have provided us with a detailed RCA, root cause analysis. Can you give it to us? Or is it confidential? My friends at Slack, please give us root cause analysis. Yes, my friends. That's my Arab accent, by the way. That's my original accent. Yes, we always. I'm gonna talk from now on the slang. We have a new run book for how to debug our systems through direct queries to our metrics backend without our observability platform. That's just Greek. There's you can't. All the Middle Eastern English is exactly the same, right? It's like always this thick accent that we have. So, yes, my friends, let's give us this. So they have a new run book for how to debug our systems through direct queries to our metrics. So that's the observability thing that we talked about. So they are hitting the database directly, I guess, or they are SSHing into like all of this stuff. Like I would be surprised. Like yeah, we just SSH into the thing, and we run our observability. Like why can't you just say that? Like you have to put it in words that is confusing. Our direct queries to our metrics backend without observability platform. Just yeah, we just SSH into the damn thing. I don't know. I'm just making things up. Maybe it's more sophisticated than I just articulated. But companies usually don't let you know that their original methods. They always try to make it as vague as possible. We have prepared methods to configure some services to reduce cross-boundary network transit. Aha! That's one of the most important things. Why do you have so many cross-boundary network? Can you keep those databases and backend servers as close as possible within the same NICs, right? That would be really awesome, right? Because that, first of all, they're going to give you higher latency. Where? The reverse. Lower latency, because you don't have to jump into routers, right? Because if I send a request to an IP address within my same subnet, that doesn't go through the router. Well, it does go through the switching part of the router to point back at me, but it doesn't jump and there's no natting, there's no routing, there's no inspection of packets. There's just, it happens at layer 2. We'll just look at layer 2, the frame, and then just move it around, right? It's way faster, obviously, than going through the switch. We have increased our open handle provisioning service workers. Guys, I think this is useless. I think this is absolutely useless. I don't know. I really don't think you guys do have to do this, because you will never hit that file limit. It's unnecessary. The problem that happened to you was outside your kind of jurisdiction. That's not the word. Outside of your control. It's outside of your control. You couldn't control the network latency. That's what it's like saying someone just plugged the electricity, just plugged all the wires, and you all of a sudden lost all your backend. What are you gonna do? Are you gonna provision 1,200 servers? Maybe you just turn back those servers on, right? That's what you're gonna do. You're gonna restart them instead. Yeah, so I still don't think there is a use case for provisioning in 10 minutes 1,200 servers. It just sounds absurdly high. I'd rather just restart my existing services if everything went fine, right? Our cloud provider has increased the API limit on the cloud service API we call as part of the provisioning process. Again, I don't think that's necessary. Sure, you guys know your architecture better than I am. I don't think it's necessary. Because you should never hit that API rate limit. I mean, how long have been Slack running? When was Slack first shipped? 7 years ago, 2013. Since 7 years ago, you didn't have to increase that limit until now. Why? Did you actually need that increased limit? Maybe yes, maybe no. I still don't think you guys don't need it. I might be wrong, obviously, on anything I say here. We will create an alert for packet rate limit between network boundaries on the network, our cloud. This is extremely way more important than increasing the stinking API limit, guys. This is important because that what caused the backend servers to be marked as unhealthy, because the request couldn't even reach the server to begin with because the packets were falling and dropping. Right? That's important. We need to know when packets are disappearing, the packet rate. If the packets are starting to drop, that's a good identifier. So I don't know if they have access to that, though. That would be interesting. So what Slack is doing essentially is just like they're essentially making their software, their platform, even more stickier with Amazon, if that's the case, because the routers or those packet limits are all in the Amazon AWS. So they must have built those APIs to interact with those routers, which is obviously an AWS APIs. So good luck moving out of that platform now, because now you just like increase the stickiness between the Slack architecture and the cloud provider, because you're doing all that stuff, and it might be okay. It's not a big problem, right? But just be aware of that. It's just something to be interesting to think about. We will increase the number of provisioning service workers to improve our capacity provision. This will be complete. I don't know why I would do that. Again, I don't see a value of increasing the service workers. Again, guys, service workers is not the service worker in the browser that Chrome's come up with, right? This is a completely different thing in the backend. This work will be done 2020. Okay. On February 12th. We will improve observability on our provisioning service. This work will be done by February 12th. I kept saying February. This is the Arabic way of saying February. So excuse me, because I can only talk for a certain amount of time in English, after which I deplete and go back to my original accent and language. So the same thing happened at work. So if I am in a long meeting, I would speak English, but after which, and I get depleted, because I do a lot of translation in my mind to translate English to Arabic in order to understand it and then speak, and then after which I just die. I start leaking Arabic words left and right. So be mind of that. The longer the video, you should have started seeing it by now. We will load test our provisioning service. This work will be done by April 13. That's a good test. Just load test it. I mean, yeah, not that you're gonna hit that, in my opinion. We will revisit our backend server scaling automation to ensure we have the right setting for predictive scaling, rate scaling, and metric that we have to scale. That is way more important than actually increasing the provisioning service. Looks like this is a very knee-jerk reaction. It's like, hey, make it better, make it bigger, make it bigger. No, make it smarter. That's what you're doing. This point. That's dope right there. Make the scaling automation smart enough to know, wait a second, why the heck am I scaling 1200 servers? Can I leverage some of these unhealthy one and maybe revive them back? We will improve our run books. What is a run book? For debugging network issues. Is that the monitoring system? This work will be done. Well, isn't that exactly what you guys mentioned right here, the packets? I guess it's the same thing. Networking issues. Yeah, networking issues is very important to kind of notify. We will investigate and test two settings of our backend servers. The first is the request timeout. That's very important. I said that. And the second is the number of simultaneous requests being handled. The request timer is so important, guys, right? Because most of these requests, remember the 40% of these requests being just waiting for things to happen, and the server just spent a lot of time waiting for a request to happen, and it will never happen, right? So not increasing, decreasing a timeout so that they time out faster, so they can break that, so they can free to serve other stuff is way more important, in my opinion. So they are revisioning this, and again, they have to investigate. There is no one value that helps here. You gotta try. You have to kind of look at the request. What's the nature of this request? Because I work with these things on a daily basis, and there are requests that you just can't time out. Why? Because the input parameter to that request kind of change completely the response, and the different parameter. One parameter can give you 1 minute response. The other parameter can give you a 300 millisecond response. It's unpredictable. It's not deterministic, as computer science people say. By adjusting these values, we may be able to prevent a small number of requests from using the majority of the resources in the backend. That's very important, very clever. People, the Slack people are on it. April, they're gonna do this work. Guys, what do you think about this? This is very interesting. I'm gonna please leave your opinions, and let me know if I said anything that is correct. And let's have a discussion. This is a very interesting one. This is different than the Microsoft outage that I talked about, than the Google outage that I talked about, than the Amazon outage. The three outages were caused by, for the lack of better term, bugs in the architecture. Slack, they have a solid architecture, in my opinion. Apart from the cross-boundary request, I would fix that. But the networking latency they have no control over it. It's like pulling the electricity underneath you. It's like powering off the whole thing. Just like bleh, remove the outlet. What can you do? You don't have electricity. It's like you don't have networking. Can't do anything, right? So yeah, but the lessons that Slack, I love their messaging here. The way they wrote the paper, they didn't blame anyone. They said, hey, we're gonna do better. They said, hey, all this part, it's not their fault, but they didn't become defensive, and that's the real engineering. That's elite, cool engineering. Thank you so much for watching, guys, and listening. For those who are listening to this in the podcast, subscribe for more backendish discussions, topics, news. And my name is Hussein. I'm signing out. Thank you so much. Stay awesome. I'm gonna see you on the next one. You guys stay awesome. Goodbye.